Section 7.2 Systems of linear equations in three variables. So the last we did systems with two variables and two equations. And so here, if we have three variables, a solution of a system in three variables is an ordered triple of real numbers that satisfy all equations. And our system solution would be written as x, y, and z. And so if we want to check if this ordered triple is a solution to the system, then we can say this is x, y, and z. So we need to plug it in to the first equation. And so in this case, x is -1, y is -4, and z is 5. So we get -1, -2 times -4 is +8, plus 15. -1 plus 8 plus 15 is 22. And so 22 is equal to 22. So this order pairs a solution to the first equation. Now we need to check the second equation. Remember, a order pair is a solution only if it satisfies all three equations. So here we get -2 plus 12 minus 5 is equal to 5. So here we get -2 plus 12 is 10, minus 5 is 5. So that satisfies this equation. And last, we check the third equation. So x is -1, y is -4, and z is 5. And so we can see here that -32 is equal to -32. Therefore, the order pair -1, -4, and 5 is a solution to the system. Okay. What we want to do now is solve for that solution. And so these are just some steps that we can take. First, we pick a variable to eliminate using any of the two equations. Then we want to use the equation that wasn't picked in step 1. And we're going to use the to eliminate the same variable. And then that will create a new system with two equations, which will use the previous methods from section 7.1. And then we back substitute for the remaining of the variables. What I like to do here is I like to call these or label these equation 1, 2, and 3. And so here I'm going to go ahead and choose equation number 1. And equation number 2. And then I'm going to choose a variable that I can get rid of. So notice here we have -z and +z. So I can get rid of that using the elimination method. So x plus 3x is 4x. 4y plus 2y is 6y. My z's will become 0. 20 plus 8 is 28. So I'm going to call this equation number 4, since it creates a new equation. Now in step 2, it asks for us to use the third equation since we haven't used it. And we can choose either equation 1 or 2 to help us get rid of the same variable z. So I'm going to use equation 1. And notice that my z's here don't have the same coefficient. So I'm going to rewrite this equation by multiplying all of this by 2. So I end up with 2x plus 8y minus 2z is equal to 40. And then the top one remains the same. So now that we multiplied by 2 all the way across the equation, notice that the z now has opposite coefficients, so we can add these two equations. So -16 plus 40 is 24. So I'm going to call this equation number 5. Okay, so notice now we have two equations with two variables, so I can use both of those equations. So I'm going to write them here. So we have 4x plus 6y equals 28, and 4x plus 5y equals 24. So now we can get rid of a variable here. Let's get rid of the x's. So I'm going to multiply this equation by -1 to get negative 4x minus 6y equals negative 28. And the second one will stay the same. So we can add both equations. Negative 4x plus 4x is 0. Negative 6y plus 5y is negative y. Negative 28 plus 24 is negative 4. So y is going to be equal to 4. Now we can back substitute. So we're going to back substitute into the following equation. So we can back substitute. And first you want to back substitute into equation 4 or 5. So let's choose equation number 4. Okay, so we just found out y is equal to 4. So I'm going to substitute 4 for y. Subtract 24. So x is going to be equal to 1. Now that we know that x is equal to 1, y is equal to 4, then we can back substitute into one of the original equations. Let me choose, let's choose number 2. Again, it can be any equation. Okay, so we know that x is equal to 1, y is equal to 4, 3 times 1 is 3, 2 times 4 is 8, 8 plus 3 is 11, subtract 11 on both sides, and so we get z is equal to negative 3. So my solution for this system is x is equal to 1, y is equal to 4, and z is equal to negative 3. Okay, let's look at another example. Example 3, same idea. We want to find a solution to the system. So we can pick any of the equations. I'm going to go ahead and work with equation 1. So I have 2y minus z equals to 7. And we look at number 2, which is x plus 2y plus z equals 17. Notice that the z already has opposite coefficients, so I can just add. So I'm going to get x plus 2y plus 2y is 4y. The z's become 0, equal to 24. So I'm going to call this equation number 4. Then the third equation I have not used, so I'm going to go ahead and write it here. And I'm going to use equation number 1 to help me get rid of the variable. So here, notice that the z's don't have same opposite coefficients. So I'm going to multiply this equation by 2. So this would become 4y minus 2z equals to 14. And the top one remains the same. I can add the equations. 2x plus 0 is 2x. Negative 3y plus 4y is y. My z's become 0. Negative 1 plus 14 is 13. And so that is equation number 5. Okay, so now I can take equation 4 and 5. So this is equation 4 and equation 5. And we can decide to get rid of a variable. Let's get rid of the x's. So I'm going to multiply the top by a -2. So this would be -2x plus -8y equals to -48. The bottom one remains the same. So the x's gives me 0. -8y plus y is -7y. And -48 plus 13 would be -35 divided by -7. And so y is going to be equal to 5. We can back substitute into equation 3 or 4. I'm going to go ahead and pick equation number 4. So I know that y is 5. Subtract 20. So x is equal to 4. And so I can now back substitute into the original equations. I'm going to go ahead and use the first one. So here y is 5. Subtract 10. So we get -z is equal to -3. So z is equal to 3. So my solution is going to be x is 4, y is 5, and z is 3. Okay. Example number 4. We can start with equation 1. And we can go ahead and start with equation 2. And so we can choose to eliminate the x's or the y's or the z's. I'm going to go ahead and pick the y's. So in order for these to cancel, I need this to be a positive 3. So I'm going to multiply this equation by 3. So this will become 6x plus 3y minus 6z equals to -3. And this will remain the same. 6x plus 3x is 9x. The y's become 0 minus 7z is equal to 2. So that's my equation number 4. Now I'm going to use equation number 3. And I'm trying to get rid of the y's again. So I'm going to use equation 1. And I want this to be a positive 2y, so I'm going to multiply by 2. So this is 4x plus 2y minus 4z equals to -2. This one remains the same. 4x plus x is 5x. Y gives me 0 minus 3z. 3z plus -4z is -z. 6 minus 2 is 4. So that's equation number 5. Now I can use equation 4 and equation 5. And so I'm going to choose to cancel z. So I'm going to multiply this by a -7. So this would be -35x plus 7z equals to -28. The top will remain the same, 9x minus 7z equals to 2. So we can add these. So we're going to get 26x is equal to 26. So x is going to be equal to 1. Okay, so we can back substitute. I'm going to use equation number 5. Again, you can use equation number 4. So x here is 1. Subtract the 5. So negative z is equal to negative 1. So z is equal to 1. And then finally, I'm going to back substitute into one of the original equations. So I'm going to choose equation number 3. Again, you could choose equation 1 or 2. Here x is 1, z is 1, 3 plus 1 is 4, subtract the 4, 6 minus 4 is 2, so y is negative 1. So my solution is x is 1, y is negative 1, and z is 1. Okay, and then the last example is a word problem. So it says a certain brand of razor blades comes in packages of 6, 12, 24, consisting of 2, 3, and $4 per package. A store sold 12 packages containing a total of 162 razor blades and took in $35. How many packages of each type were sold? Okay, so the first thing we can look at is the number of packages. So the number of packages, we know that we bought a package of 6. So packages of 6, let's call those X. Packages of 12, let's call those Y. And packages of 24, let's call those Z. And we know that all together, it should give us a total of 12 packages. So that's the equation for packages. And then we have the number of razors. So the numbers of razors, in the first package, it comes in 6. So we're going to have 6x plus the second packages come in 12 and the third come in 24. And altogether, the total number of razors was 162. And then the third situation is the cost. So we know that the 6 packages cost $2. The 12 one costs $3, and the 24 one costs $4. And altogether, we made $35. So we have 3 equations, x plus y plus z equals 12, 6x plus 12y plus 24z equals 162, and 2x plus 3y plus 4z equals 35. So we can number these to keep track of them, and then we can use the same method. So I'm going to use equation 1 and equation 2. And I'm going to choose to get rid of the x's. So I'm going to multiply this by negative 6. So that becomes negative 6x minus 6y minus 6z is equal to negative 72. And this equation remains the same. So if we add them, we get 6y plus 18z is equal to 90. So that's equation number 4. So now I'm going to use equation 1 and equation 3. And again, I'm going to cancel out the x's. So I'm going to multiply the whole equation by -2. And the third equation will just remain the same. So the x's will become 0. -2y plus y is y, plus 2z is equal to 11. So that's equation 5. So now I use equation 4 and 5 and solve the system for those two equations. So I'm going to get rid of the y, multiply that by -6. And the top stays the same. 18z minus 12z is 6z. Divide that by 6. So z is equal to 4. So we're going to back substitute into equation 4 or 5. I'm going to choose equation number 5. So here we know that z is equal to 4. Subtract 8, so y is equal to 3. And then finally back substitute to the original equation. So here we know that y is 3, z is 4. Subtract 7. So we get 5. So my solution is x is 5, y is 3, and z is 4. It's a word problem, so we can write a sentence. 5 packages of 6, 3 packages of 12, and 4 packages of 24 were sold. Okay, so this was section 7.2.